The air in a room with volume 180 cubic meters contains 0.15% carbon dioxide. Fresh air of 0.05 carbon dioxide flows into a room at the rate of 2 cubic meters per minute, and is mixed thoroughly, and it flows out at the same rate. What percent of carbon dioxide is in the room as a function of time? The volume of the room is 180 cubic meters. Fresh air with only 0.05% of carbon dioxide is entering the room, mixed and flows out at the rate of 2 cubic meters per minute. We let Y be the amount of carbon dioxide in the room as a function of time. When time is 0, initially, the amount of carbon dioxide in the room is therefore 0.15% times 180, which is the volume. And this will give us 0.27 cubic meters. This is the amount of carbon dioxide in the room initially. The volume of the room is fixed as 180 cubic meters. And so the percentage of carbon dioxide in the room at any time is the amount of carbon dioxide Y of T over the volume times 100%. And this is 1 over 180 Y. This is the percentage of carbon dioxide. The rate at which the carbon dioxide is entering the room is 0.05% times 2 cubic meters per minute, and this is 0.001 cubic meters per minute. The carbon dioxide is then thoroughly mixed and flows out at the same rate. So the rate at which carbon dioxide departs the room is the percentage, which is Y over 180, times the depart rate, which is 2 cubic meters per minute. And this will give us 1 over 90 Y. The unit is cubic meters per minute. So the rate at which the carbon dioxide in the room is changing at any time is the rate in minus the rate out, 0.001 minus Y over 90. Rewrite this equation 0.001 minus 1 over 90 Y. We recognize that this is of the form Y prime equals m minus ky, and so we solved it already. The solution is Y equals m over k plus a e to the negative kt. M is 0.001, k is 1 over 90, a is the unknown constant, e to the negative t, and k is 1 over 90. Simplifying this, we get 0.09 plus a e to the negative t over 90. But initially, when time is 0, there are 0.27 cubic meters of carbon dioxide in the room, so we plug in t equals 0 and y equals 0.27 so that we can solve for the constant a. Solving for a, we get 0.18. So the amount of carbon dioxide in the room at any time t is 0.09 plus 0.18 e to the negative t over 90. As t goes to infinity, then the second term goes to 0, and we see that the amount approaches 0.09. But the volume of the room is 180, so 0.09 over 180 is 0.05%, which is the percentage of carbon dioxide that flows into the room. In the long run, the percentage of carbon dioxide in the room is also 0.05%. This equation represents the amount of carbon dioxide in the room as a function of T. What we're looking for is the percentage of carbon dioxide in the room as a function of T. To obtain the percentage, we simply take the amount, which is this function, divided by the volume, and the volume of the air in the room is 180 cubic meters. And so the function p equals, p for the percentage, y of t divided by 180, but y of t is 0.09 plus 0.18 e to the negative t over 90, and we take this divided by the volume of the air in the room. We obtain a new function, p equals 0.05 plus 0.1 e to the negative t over 90%. Here, as t go to infinity, the second term go to 0, and we get the percentage to be 0.05%, which is the same as what we got earlier, 0.05%.